Hi, everybody. Whoa, and down the volume. Thanks for coming, and still coming. Excellent. I'd just like to start with two things. First of all, to acknowledge that I'm standing on Wujak Noongar land, and I'd like to acknowledge the leaders, past, present, and emerging. And second of all, I would like to acknowledge you. Thank you for giving up 40 minutes of your time, of your life, to come and hear me talk. So thank you. Thank you very much. Over the next 40 minutes, I'm going to take you on a bit of a fun journey. I hope you have as much fun listening to what I'm going to say as I'll have presenting it. So no matter what you might think, this is not a blockchain talk. So sorry, if you're here for a blockchain talk, you've come to the wrong place. You've probably come to DDD 2 or 3 years ago. That's where you would have got the blockchain talk. This talk, oh yes, it's generative AI, yes. But this is generative AI talk that Derek put together. So it's not the usual, oh, this is my product's amazing, look at it, no. This is how Derek taught himself generative AI, and in fact, a key part of the generative AI stack. And so, as a software developer, a very old and, as Matt would attest, very crusty software developer who's trying to get his head around what this generative AI thing is, I went on a bit of a journey, and I'd like to share that journey with you today. And what I wanted to teach myself was agentic workflow. So has anybody heard of agents when it comes to Gen AI? A couple? Hi, Christian. How you doing, man? A couple of people have heard of agents, which is great. You'll get something out of this talk. But all the people who didn't put their hands up, you're going to get a lot out of this talk. Because, like me, 6 to 9 months ago, I knew nothing about agentic workflow and agents. And so you're going to go on the same journey I went on. Believe it or not, does anybody use any of these tools? So this is all of the IDE code tools that we currently use, well, what I use on a day-to-day basis. We've got Cursor, GitHub Copilot, and the last one, which I am blocking, is Amazon Q. Does anybody use that for building software at the minute? A couple, yeah, a couple. So these are agents. These are the agents that you're using day to day. Now, all of these applications or agents that you can use are all excellent. The one I use the most is Cursor. So if you're thinking about software engineering and improving how you go about building software, have a look at Cursor. It will help you a lot. But these agents, like all things in Gen AI these days, are evolving really quickly. And so what they're actually doing now is enabling you to change the underlying model that they're making, which to me, now that I know a bit about Gen AI, is fine. But if you think about it, and there's a link there, you can actually use AWS with GitHub Copilot, where GitHub Copilot connects to the model being hosted on AWS. So you can see this interoperability and how agents are actually very, very fixable. So you're not really fixed to one particular platform, which is really interesting. But when I go to Gen AI talks, I usually see a lot of really boring examples of agents and how to use Gen AI, or I hear things like, oh, what's the use case? What's the use case for this Gen AI thing? And really, there's a lot of use cases. I'm going to go through two really interesting ones that I've come across over the last 6 months. The first one is this. Has anybody seen Waymo? Yeah, a few. Excellent. So Waymo is a self-driving car. This is an agent. It's a cool agent, and how it works is using an app, you can order your Waymo car. This is in San Francisco. It's also in a number of other cities throughout the US. You get your app, and you say, okay, I am here, just like Uber, I am here and I want to go there. And a self-driving car rocks up to your location with your name flashing in lights around. Very disconcerting because there's nobody driving. It stops, you bring your phone to the door, and the door opens. And then you get in the car, there's a screen that you can see there in one of the, in two of the diagrams. It says, welcome, Derek. I'm taking you to your destination. Close the door, buckle up, and off I go. And the wheel starts to move by itself. When you first see that, it's a diaper-changing experience. Let's put it like that. That's an American phrase, by the way, diaper. So the car takes off, goes to traffic lights. The first time you hit a traffic light, you think, I'm going to stop, I'm going to stop, I'm going to stop. You stop. I'm still here. And it just keeps going and takes you to your destination. And it uses agents to do that. So an agentic workflow is working inside the car or with the cloud, and it's working out how to perform a particular task. And that is the first understanding that you must understand when it comes to agents. An agent is nothing more than something that's trying to perform a task that you ask it to do. For Waymo, it's getting you from point A to point B. The fact that the car is driverless is amazing. The second evolution, and this is how agents are evolving, is something called computer use. And this just came out very, very recently. So what computer use does is it's a way of an LLM, or large language model, in this case Claude 3.5 version 2, orchestrating, which is the second key thing an agent does, orchestrating a task. So this task was done by a friend of mine called Mr. Michael Chambers. He used computer use to order a pizza. Now, the link there is to the video, which goes into a bit of depth of how he did that. But really, with computer use, you're giving the agent use of your computer, all right? Which is scary, but it's a sandbox computer. And you give it as much information as you need. So when you're ordering a pizza, for example, you give it your account at the pizza place you want, and your address. And, of course, a little bit of money. And that is a picture of the pizza arriving at Mike's house and the computer use actually invoking. So if you want to learn more about that, that's that link there. So that's the use cases for agents. Agents are cool. There's a lot of great use cases. And this is the slide where I usually talk about me. But I'm not going to talk about me today because this talk is not about me. This talk is about Rocky. And this is Rocky. Rocky is the Minecraft agent that I built to learn about agents. So Rocky is called Rocky T Bot. They're also a 6 months old. Skills are digging, hide and seek, and building. And Rocky has traveled well this year. Rocky has been at the AI World's Fair in San Francisco. That's where he may have taken that Waymo photograph. Serverless days in Sydney and Auckland, and many other places, including where I'm from, Belfast. And the framework that Rocky knows the most about is called Mindflayer. So Mindflayer is an open source framework that you can get today, and you can sidecar it into Minecraft and control a bot. So if you want to run a procedural bot, you can use Mindflayer, write some TypeScript code, and it will do what you tell it to do in a very procedural manner. Rocky knows Mindflayer, and he knows TypeScript and prompt engineering. And this is the third really important thing, is prompt engineering is absolutely vital if you want to know about agentic workflow and agents. Okay, so it's tasks, orchestration, and prompt engineering. Those are the three fundamental building blocks of agents. So this is Rocky. And so if you think about agents as a workflow, this is the key part, the key components left to right. You have a user interacting with your agent, either via chat or by sending it some unstructured data. Agents will ingest both of those. The agent itself, as I said before, is an orchestrator, right? So it brings in the task as part of the chat or as part of the unstructured data and orchestrates the outcome. So it thinks, okay, the user is asking me to do this. I need to orchestrate various things to get an outcome. And the things that it needs to orchestrate are tools, so calling out to external APIs, calling out to applications, calling into data, using other third-party services, and also using an LLM, a large language model. So that's the magic. So knowing this and knowing this about agentic workflow, let's make it interesting, I was thinking. Let's think how I can learn this and make it interesting. So let's bring Minecraft in. Minecraft is a way that has a chat feature. Let's use that as a way of setting the task for the agent. And the tools, well, in Minecraft, there's lots of tools. You can build, you can dig, you can jump, you've got location. All of these things can put up your tools. You have the agent, which is the thing working out what I need to do with my Minecraft bot. And it will help you. And it will find out what it needs to do for the task. And then we've got the LLM, which is magic. It is magic. And then we've got all of those things being orchestrated via the agentic workflow. And this is what we built. Now, Rocky comes in. So you need to control Rocky via chat in Minecraft using the tool set. And the tool set that we started to build out are jump, move to position, locate a player, etc., etc. So here's Rocky. It's raining in Rocky Land. And what we do first is, if you see, we open up a chat window. What's the weather like? So Rocky, using MindFlare, will look into the Minecraft environment, work out that it's raining, and then return a response. Hey, it's raining. Rocky, can you jump? Rocky can jump. Anything else I can do for you? Well, there is, Rocky. Well, so here I'm going to play hide and seek with Rocky. So I run around the back of this building, and I ask Rocky, can you find me? And Rocky, using, again, MindFlare as the tool, goes in, finds my location, and then uses a Pathfinder algorithm to go, Derek's here, let's go find him. Also, Rocky can find elements inside the Minecraft world. Again, we use the tool set that's available in MindFlare that knows about every entity in the Minecraft world. It'll get its X, Y, Z coordinate, and it will send Rocky on its way. So here goes Rocky, running away. You have to run really, really fast to keep up with Rocky. It'll find a pig, and it'll stand beside it. Obviously, the next thing to do is ask Rocky, can you hit the pig? Because, and this is unfortunately human behavior we found out as Rocky hits the pig. When we demoed this at various exhibitions and summits, most things that people did was hit things and dig Rocky into a hole and fill it in. So, yeah, humans are bad. And then finally, I think in this recorded demo, I think it'd dig a hole. Yeah. So we can also dig a 2x2 hole. So we can constrain the tasks that we ask Rocky to do, okay? So when we think about agentic workflow, where we have got a task, we give it to Rocky, Rocky uses the tools that they've got available to then get a result. And also Rocky can dig himself out of holes, or dig themselves out of holes. And so, Rocky, come here. So that's a very brief overview of Rocky. There's a lot more. I'm going to do a live demo at the end. to really look through all of the cool things that Rocky can do, because there's a lot more. So let's start about the architecture. How do we build this thing? So it started off as a concept. Minecraft you can get as a container. So you can go to GitHub, you can download the latest version of Minecraft as a container, deploy it on AWS using, you can run it on EC2, and you can run an agent on EC2, and you can run the LLM on EC2 and interact them together. That was really boring and not really where I build software on, because I like to extract all of the complexity of the operating system, etc. away. So let's evolve that into ECS. So in a container, this time running on Elastic Container Service, we have Minecraft, the agent, and the LLM. And that worked really well. No problems at all. But then we really wanted to deploy it in a serverless ecosystem. So we thought, okay, let's run Minecraft on ECS, and then we can run a agentic workflow library inside Lambda. And then the Lambda could talk to an LLM that's running inside SageMaker. And so this was the initial version. So the initial version, we got working with Rocky doing very basic tasks. But we quickly found that because Lambda has a timeout of 15 minutes and a certain capacity constraints, we were finding that the lag and the time it took for it to respond, the agent to respond to the task, was quite high. And so we had to, the first time I presented Rocky to the world was at Serverless Days. And so we needed to improve that. And so we improved it by actually using a new feature that came out, luckily at the same time, which was around agents for Amazon Bedrock, which was a fully managed agentic workflow service. And what we did was we went, okay, ECS, in the container service, we'll run the Minecraft container, and we'll run the Rocky Mindflayer agent part. And then that will communicate to agents for Amazon Bedrock, which will run the tooling. It will run the interaction with an LLM. A good thing with Amazon Bedrock is we could mix and match the LLMs depending on the task that we used. So that actually worked out as the best solution. And then that architecture evolved again to what I'm going to demo today, where I've got Minecraft on my local machine. I've got the agent TypeScript executable running as well, and then that feeds up over the internet to agents for Amazon Bedrock. So a quick word on agents for Amazon Bedrock. So Amazon Bedrock is how you can communicate with multiple different models behind a single API. So here's a list of all the models. I think Anthropic is one of the big ones. So Claude by Anthropic is one that I'm going to use today, but you can also use the meta ones like Llama 2 behind Bedrock. So a single API, which is pretty handy. And as well as that, there's a number of other features. One of those is being agents. But also you can apply guardrails, because guardrails are important. You can apply knowledge bases, which is RAG, so manage RAG, and also you can evaluate each model. So what was really handy for me and saved me a lot of time was a few features. Automatic prompt creation, because prompts are tricky. Anybody who says to you, Gen AI is easy because prompts are just plain English are lying. Automatic prompt creation that Bedrock applies is very handy, saves me a lot of time. It does multi-steps, so you can orchestrate many steps. You can also trace through the chain of thought. So the chain of thought is how the agent works out how to respond to your task. And also, and what we use a lot in this particular demo, is something called return of control. So what return of control is when you call from your client out to your agent, which is running on Amazon Bedrock, return of control will then return back what it thinks you want, and then it'll grab some more information, go back, think some more, grab some more information, and then it'll work in multiple steps, trying to satisfy the task that you've set it. So this is how you create an agent. This is Amazon Bedrock. You go in, you go create agent, you give it a name. And so this is the one we recorded for serverless days. Once you give it a name, it's very, very simple. Then you select one of the models that are available from Bedrock. So there's a lot. So I'm doing Claude Haiku. So the reason that I use Claude Haiku for Rocky is because Claude Haiku is what we call a small model. So it is faster response times. So some of the simple tasks that we get Claude to do, like jump, uses Haiku. You then start testing the agent. So you can say, what is the time? So agents have no concept of the outside world. Okay? So this is just using an LLM. The agent's going to the LLM. The LLM's no idea what the time is. So this is where you start adding tools. And into tools in Bedrock are called action groups. So you create an action group, which I'm calling really simple action, and then you go in, and inside the action group, this is where you set up the invocation. So you can invoke a Lambda function. You can use an existing Lambda, or you can use return control. Park the return control until we look at Minecraft. So this one's going to invoke a Lambda function. The Lambda function is going to go off and find the time for us. And then it's going to return back with the response. And that way, we can add the ability for the agent to know about time. The same way we've added the ability of the agent to know about things in Minecraft. And so this is the actual Lambda function that's created for us. We then add some code to return the current time. So again, this is in Python. So I'm not the best Python developer in the world, but we do time.local. So time.local in a Lambda is not going to give you the correct time, but it'll give you a time. But there are time services that you can query via an API out of a Lambda, which will give you the right time. So now with that Lambda created, we then can re-exercise our new agent. And we then ask it the same prompt. Hello, what is the time? And this time, we've got a time, which is 1:09:51. So that's very basic creating an agent in Amazon Bedrock, right? And it shows, that's there to show you the concepts. You create the agent, and then you add the tools. The tools add the features that you want and help the agent satisfy the tasks that you send to it via the prompt. I hope everybody's coming along. Okay, this is the sponsors. Thank you, sponsors. This presentation wouldn't be possible, and this today wouldn't be possible without those. Some great sponsors in there as well. So, Rocky is bored of slides. I'm bored of slides. I hate slides. It's time to try the live thing. So, you're going to meet Rocky in person. And if the internet works, my caffeine levels are high enough. Let's go. So, this is Minecraft. Is anybody a big player of Minecraft? A few people. Okay, people. Has anybody not seen Minecraft? Okay, Minecraft is a game. You build stuff. So, this is Minecraft. And this is the local agent. So this is a TypeScript application that's running on my computer, right? And it knows about Minecraft. I'm just making sure you can see that. Can you see that at the back? Is that legible? Yep, we got some thumbs up. Good. So it knows about it because in the EM file, we go, okay, we're running in localhost 127.0.0.1, and the port that Minecraft's listening on is 255.65. So that's how this application is interacting with Minecraft. And inside this application, we have actions, okay? Let's not look at build now, but let's look at dig. So this is basically the TypeScript code that's telling MindFlare how to dig a hole, right? And so it's an action. It's just TypeScript code. And I've got a number of actions for all of these things, okay? So they're running locally. But hold on, Derek, where's the smarts here? All of this is a procedural code that controls a bot in Minecraft. Well, the smarts are actually in the agent. This is the agent. And the agent here that we're using today, the simple actions like dig are using Claude Haiku. And you'll see this prompt here, and if you can't see it, I'll read it for you. This is the most work that went into this, was getting the right prompts. You are a playful, friendly, and creative Minecraft agent named Rocky. Your goal is to entertain players and collaborate with them for a fun and gaming experience. And there's a few more lines that help Rocky set the scene. So this is applying context for the model to understand. Then we've got actions. So if I go into the actions, you'll see all of my actions are return control, okay? So they're not calling out to an external API, they're returning back to the caller. So when I put in a prompt from Rocky, it's going up to the agent's going, I need more information to actually satisfy this request, return control. And so it goes back to the application, TypeScript application, and it goes, I think you need to run action jump. Or things that need a parameter, like dig, it'll prompt you. How big do you want the hole? How wide do you want the hole? So that's how return control works. The agent is orchestrating in the background. It's going, okay, I've been asked to dig. How big is the hole? Do I know that enough information? No, let's return control. Get that information. Do I know where the pig is? Let's return control and find out where the pig is. Go back up to the agent. Agent does a little more processing and then throws down the action, the things it needs to run, plus all the parameters that action requires. So how does that work in reality? So let's start Rocky off. So I start TypeScript, it says bot spawned. I then go into Minecraft. And there's Rocky. Rocky has appeared. Hi, Rocky. I should do the wave right now. I haven't written a wave action. And so you go type, hi, Rocky. Hi, Diggleby. How's it going? Want to play a game? Alrighty, let's play a game with Rocky. Let's play hide and seek. Let's see if Rocky's working. Can you come find me? On my way. And so Rocky is able to find me, and then I can ask it. Oh, now it's jumping. Oh, and now it's digging. So this always happens, okay? Not in this order, but if you give what are we talking about? Agents. And so what you're doing is you're giving something an indeterminate prompt. And you're expecting an indeterminate response. So sometimes you will get behavior that's indeterminate, okay? Which is fun to demo, but in reality, that's where guardrails come in. So if you're building an agent in the real world, not a fun game like Rocky, you need to apply things like guardrails to stop the indeterminate responses really messing your day. Please come here. Come on, Rocky. Yay! Again, there's no dig out of the hole action. This is something that's evolved based on the actions that we've given Rocky. Rocky has a pathfinding, knows about pathfinding. Rocky knows how to dig. Rocky doesn't know how to dig out. Okay, so Rocky's worked that out. That is so some of the emergent behavior that we see from agents. Okay, I see a cow over there. Can you? Oh, by the way, I'm from Belfast, so cow is actually a cow, right? Can you find a cow? Yes, found a cow. Please go there. And so let's see, Rocky, go, Rocky, go. So again, pathfinding. Rocky. Okay, found a cow. I will not hit the cow. I've already showed you that Rocky can hit things. But let's go into, that's the basic behavior. There's a few more actions, and I'm going to share this is all open source, so you can have a play with this. You can actually run this and add your own actions, and I'll share everything at the end. But that's the simple actions, which use the Claude Haiku model. But this is Minecraft, and in Minecraft you build. So who wants to see Rocky build? Yes, let's go building. So let's clear some space. Okay, so building is a complex thing to do, because in Minecraft you have a block type, you have an XYZ coordinate of the thing that you're building on top of, you have a plane that you want to build on, plus you want to place the next block on that plane. So when you say, oh, I want Rocky to build, it's actually harder than you think. But let's see what happens. So this is where I ask somebody, what do you want Rocky to build? A what?
Fence for the cow. Something around the cow.
Something around, a fence. Yeah. It's a fence for the cow. I'll just build a fence. How does that? Build a fence. Somebody said house. I've done a house. Okay, so this takes time, so I'll show you what happens. So here we have the build prompt, right? So the build prompt is massive. So it says, you're Claude, an expert Minecraft builder. Given the structure there, so if you see that, that's the JSON format that Mindflayer expects that buildings are in. And so you give it an example. And then you add more information to the prompt. In the context, you give it a list of valid blocks, because we found that if you give it infinite blocks that it can build with, it will take infinite time to get a response. So we've got valid blocks, and then here, the input, this is the return control. The LLM has went, that prompt is fence. It's shortened it to fence. And then it responds, it started responding with all the blocks, the Mindflayer code that it needs to do, and it's starting to build. That's not there. And so Rocky has built a fence, and we should have put the cow inside the fence. But there we go, Rocky has built a fence. Now, what that does, usually people clap here, because that's really, that was hard to do. You have no idea. Thank you. And so the code for that is actually in the build source. So if I quickly show you that, you'll see there's the prompt. So all of that JSON format is in prompt.txt, and the action build is here. So this is where it takes the response and it converts that into actual actions to do, okay? And that's how it works. Okay, one more thing to build. Let's just change the time. Set time noon. Nope. Time set noon. How many times have I done this? Not enough, obviously. Okay. Please come here. Go my way. Still, who said no? My goodness. Okay. we have got time for one more. Who wants it to build something else? Colosseum! We only have 3 minutes. Anyway, can you build, I don't know how to spell Colosseum. Colosseum. Okay, let me see. I want to see what it does. Okay, scroll down. Okay, it thinks it's a Colosseum. All right. Okay, so what's happening is the LLM is trying to go and find a 2D picture it has of a Colosseum. It then needs to work out what that 2D picture looks like in 3D, and it needs to transfer that into 3D space, and then it needs to work out, okay, given the JSON format of Minecraft that I've given it, plus the blocks that I've given it, it needs to then work out how to build a Colosseum. And it's still thinking. So as I said before, while it works, and you can actually get this yourself and have a play. It's good fun. And where do I get this while Rocky thinks? I'm going to leave Rocky to think. You can get it all here. So this is a little QR code that will give you a quick survey to give me some feedback, because I always like some feedback on how my talk has went. And at the end of that, you get some AWS credit codes, so you can get started in building them with the agent, and also a link to the open source repo that Rocky lives in. So please do that. That would be much appreciated. I always like the feedback comments on Rocky. They're always very, very wide and varied. Okay, so I'll just quickly see if we respond. Still thinking. So okay, look. So the Colosseum has come back to a small arena. So it's still thinking. It's when, I can't build a Colosseum. Let's try a small arena. And so I'll keep thinking. I'll keep evolving. Oh my goodness. Look at that, just on time. Rocky is building a small arena. Where are you, Rocky? No. Right. It's completely went and tried to dig the canal under this small arena so it can build the fishes that it's going to fight. Yeah. So that is indeterminacy viewed, and that is Rocky. And I think that's all I have time for today. I'll be here all day. Come and ask me questions. I think I don't have no time for questions. Right on the money. So yeah. My name's Derek. Thanks for watching. And go play with Rocky. Thank you.